All right, now we are ready for the backside. So watch this. You ready? I'm going to flip this over, and I do need all 6 of these boxes, but I actually need to double it. I need 12. So here is what I'm going to do. I'm going to fold my paper in half this way now for the backside, right? We have all this great work on the front that we already checked all those answers. We worked through them first and checked the answers after, because I promise you, you'll learn your math better that way. You still learn if you copy everything down, but just not as effectively. Okay, so on the back now, we have 12 boxes for 12 more problems. And I am going to help you through 7, 8, 9, and 10. So just to recap, on the front, we reviewed this process of I assign my variables, I find K, I write an equation, and I plug into the equation. It's a great way to solve problems, okay? Sometimes though, when we only want one specific thing and don't need a whole bunch of values from the equation, sometimes equivalent ratios is a little bit easier. So here is what question number 7 says. It's not in Canvas because we're doing it together right now. So question number 7 says, at your school, 72% of students eat school lunch. Ooh, do you remember how immediately, if they give me a percent, I'm going to start going P over 100? So I'm just going to go right away 72 over 100. Instead of using y equals kx, we are now using P over 100 equals A over B, or equivalent ratios. 72% of students eat school lunch. If there are 700 students at your school, does that sound like a part or does that sound like a total? 700 students at your school, that sounds like a total to me. So I'm going to write equals, 700 goes on the bottom, it is the base, it is what it's out of. This is P over 100 equals A over B. Does this look familiar to you? This is definitely part of the standard. At your school, 72% of students eat school lunch. If there are 700 students at your school, how many students eat school lunch? I set up equivalent ratios so that I could cross multiply and solve. So I'm going to do 72 times 700. And you can circle them like this if it helps you. If you don't need to circle them, that's fine too. But I'm going to do 72 times 700. That's a division. 72 times 700 gives me this big thing, 50,400 equals 100 times A. So now I'm solving these problems. Instead of using y equals kx, I'm using equivalent ratios, setting up a proportion, a ratio equal to another ratio. And then I'm going to go divide by 100, divide by 100. I still have this sitting here, so I'm just going to hit divide in my calculator. And I get A equals 104. So the only other thing I have to do now is, this is a story problem with the context. What does that 104 mean? Is it a percent? Is it lunches? What is it? Oh no, it's students. That's students. It's 104 students that eat school lunch. So make sure you put a label on it, 104 students. Okay, let's try another one. Here is number 8. Number 8 says, a survey reveals 252 out of 350 students in 7th grade like to read. What percent of 7th graders like to read? Oh, what percent? What percent means I'm immediately going to go P over 100 because I'm looking for the percent. Equals A over B. We'll now find the total. The total is out of 350. Okay, out of 350. And that leaves 252 to finish off our proportion. P over 100 equals A over B. Here I go. I'm ready to cross multiply. Now do these two. P times 350 is 350P. And now I'm going to do these two. 100 times 252 is 25,200. You can type anything in a calculator that you need to. Divide by 350. Divide by 350. Like this right here. I'm going to type it in a calculator. 25,200. 25,000. You guys can't see that. You guys can't see that either. 25,200 divided by 350 is 72. P equals 72, which means, what did we just find? If that's P, we found a percent. 72% of those 7th graders like to read. Okay, 2 more we're going to do together. Here are questions 9 and 10. Let's zoom out a little so you can see the questions and see what I'm writing. So question number 9 right here. You are taking a math text. Probably not. Probably a math test. You are taking a math test and you get 32 problems correct on the test. Your grade is 80%. How many problems were on the test? That's another percent one. I promise they're not all percent ones. We're just definitely starting off with that. Your grade is 80%. Okay, that's 80 over 100. How many problems were on the test? You got 32 of them right. Is that a part or is that a total? That is a part. That's not the total. We're trying to find the total, which we call B. Okay, A over 100, or P over 100 equals A over B. Okay, 80 times B, here I am cross multiplying 80B. 32 times 100 is 3200. Divide by 80, divide by 80. And we get, well, 32 divided by 8 would be 4, so 40. B equals 40. Well, what was that in this question? How many problems were on the test? Oh, there were 40 problems. It's a big test. Again, instead of y equals kx, we are setting up proportions and cross multiplying. That's what you're going to do for all the rest on the back side. Number 10 says this. Tony bought a CD on sale for $3 off the original price of $15. What percent was the CD marked down? What does that mean? Oh, what percent? Okay, P over 100. The original price sure sounds like a total to me, and it was $3 off, so there we are. P over 100 equals A over B. Here I go. P times 15 is 15P. 3 times 100 is 300. Divide by 15, divide by 15. So 300 divided by 15 is 20. P equals 20, so what did we just find? That was a 20% markdown, which is also known as a discount. All right, so those first 4 examples were all percents. If you scroll down under this video and look at the next part, you'll see they're not all percents. So I'm actually just gonna help you set up number 11, even though it is in Canvas. I'm gonna help you set it up real quick. It says for a batch of cookies, you'll need 2 cups of chocolate chips for every 5 cups of cookie mix. You're gonna use that to set up your first ratio. And the wonderful thing about this method is that you don't need to worry about what's X and what's Y. You just set up the first one and then make sure the second one matches. So again, it says you need 2 cups of chocolate chips. And sometimes I like to remember, I like to label something so that I remember, okay, this is, and I messed up my color scheme. That's supposed to be blue. So this is 2 cups of chocolate chips. I'm gonna write chocolate chips like that so I remember what's what. You just gotta remember somehow. 2 cups of chocolate chips for every 5 cups of cookie mix. So I put chocolate chips over mix. Now here's the question. How many cups of chocolate chips do you need? Oh, I skipped a part. It says you have 30 cups of cookie mix. So is that gonna go on the top or on the bottom? Well, it's gotta match where I put mix on the other one. It doesn't matter how I set this up. I can totally choose, but whatever I do on this side, make sure it totally matches on this side. How many cups of chocolate chips do you need? So you can still set up, even if it's not about percents, the whole back side, you are using equivalent ratios and cross multiplying to solve those. So you are gonna try the rest of these. You got 11, 12, 13, 14, 15, 16, 17, 18. Go through 18. That's like 6.5, 7.5 more, because I started that one for you. And then you're going to upload a picture of this backside so that I can look at it and see how you did. Do you have any questions or need any help? Of course, please ask.